wanted to give you a brief introduction into thermodynamics, and then I've got a worksheet that'll get us a little deeper into it. What we're going to do is, let me introduce the first law and the Zeroth Law. Zeroth Law, what does that mean? It means they came up with the first law, and they realized that you needed some more information, right? We needed a law before that. And so they added in the Zeroth Law later. And the Zeroth Law basically tells us that we can take something's temperature. I'll read it to you. If object A is in thermal equilibrium with object C, and object B is separately in thermal equilibrium with object C, then objects A and B will be in thermal equilibrium if they are placed in thermal contact. So what does that tell us? It tells us we can take something's temperature. If our thermometer is in thermal contact with something, and we mark on the thermometer what temperature that is, and then we take it and we put it in thermal contact with something else, and it goes to that line, we know the temperature of that object. So that's the Zeroth Law of thermodynamics. The first law is conservation of energy. What it tells us is that the change in internal energy is equal to the amount of heat we add minus the work that the gas does, that our system does. So that kind of makes sense. It also tells us that heat and work are equivalent. And so there's a couple of things going on here. But we're looking at an energy standpoint. Our system, and let's say we have a system that looks something like this. A piston, a cylinder with a movable top, a piston that can go up and down frictionlessly. And we have gas inside there, and that's our system. And what can we do? We want to know the energy of the system, the energy of the gas. How does that change? One way we can change it is by adding heat into the system. That would cause the energy of the gas to increase. And so if we look at our law, I'll just write it again over here. The change in internal energy is equal to Q minus W. So if we're putting heat in, we would call that positive heat. So the flow in is positive. I'll put it right here. And when it flows out, Q is negative. So a positive Q, heat's flowing into the system, causing the gas molecules to warm up, to move faster. Their energy goes up, right? Their kinetic energy goes up. So the change in internal energy would be positive if we added heat to our system. If we let heat come out of our system, right, the gas would cool down. It would lose energy. Delta U would be negative if Q was negative, assuming that there's no work being done, right? Well, let's just look at one thing at a time. So that's how heat can flow into or out of our system and change the energy of the system. The other thing that can happen is work can be done. The piston can move. If the piston comes down, if the volume of our gas becomes smaller, we are doing work on the system. The environment is doing work on the system. If the gas expands, the volume becomes bigger, the piston goes up, then the system is doing the work, right? You want to think about the direction of the force. The force would be up. If the gas is expanding, if the volume's increasing, the force would be up, and the piston would be moving up. And when the force and the displacement are in the same direction, the work done is positive. So that's the work done by the system would be positive when it's doing work on the environment. So let's think about what's happening here, because some books write it this way, and some books write it with a plus sign. Let's talk about that for a minute. When the system is doing the work, and the gas is expanding, the volume is increasing, the system is doing positive work, then what would you expect the energy to do? You'd expect the internal energy to go down, right? Because if the system is doing work on the environment, it's giving some of its energy to the environment, its energy has to go down. So we have a minus W here because this is the work done by the system. Some books like to use the work done on the system, the work done by the environment on the system. So in that case, if the piston is pushed down, we push the piston down, then the environment is doing work on the gas. And so if we do work on the gas, then its energy is, the gas's energy is going to increase, right? The system's energy is increasing if we are doing work on it. So that case, you'd have a plus sign here. I'll just write it below here. Work done on the system, work done by the system. Our textbook uses the first equation, and so that's the way I'm going to write it for now. Delta U equals Q minus W. It's a conservation of energy. That change in internal energy of our system, of our gas, is equal to the amount of heat that flows in or out minus the work done by the system. The heat that flows in is positive Q. The heat that flows out is negative. The work done by the system can be positive if the volume of the system is increasing, and negative if the volume of the system is decreasing. The other thing I want to point out is that this, I think I've said it before, I'll probably say it again, the piston here, the cylindrical container with the piston that can move, you might think at first that this is an artificial construct, some simple way to view a complicated process, and it is a simpler way to view a complicated process. But this is very simple, very similar to engines that we use, like the internal combustion engine in your car. There's a mixture of gasoline and air goes into the cylinder, into the piston. It ignites, it burns, it heats up. What happens when gas heats up? It expands, it does work on your car. It causes the wheels to turn, that gas is pushed out, new gas comes in, it ignites when the piston is at its lowest position, and it expands and drives the piston up, doing work on your car. And so we have engines that work just like this. So it's not just some abstract way of examining engines and how thermodynamic processes take place. It's actually a pretty it's pretty close to what we have in a lot of our engines. So I think you should take a look at it from that perspective, because it's not that different from how you got to school this morning, right? The engine that made your car run. Now we'll get into the worksheet in the next video that goes into this in a little more detail.